Hello, everyone, and welcome to Keep Simplify, and welcome to the Cloud Native Sustainability Week that we are celebrating as part of the global initiative by CNCF. Prior to this, I was just in the virtual mini conference where I and Leo, whom we had yesterday as a guest over here, did a brief introduction about the tag. There are a couple of awesome sessions going on there as well. So if you want to switch back and forth, you can do that. But I would recommend staying here to understand very interesting topic of the day, which is WebAssembly and sustainability, how they go in together. And for that, we have Kate with us. And also, yeah, we have Divya, who you saw yesterday as well. So no surprises over there. So Kate, welcome to the stream, and thank you for doing that on such a short notice. So it was like, we wanted to do this, but I and Divya weren't getting the time, to plan this out. And we usually do things async. That's how we did one of our KCD Mumbai as well. We did everything async, and we barely had any calls. So we just do it async, and it has been working out. So it worked out this time as well. And thank you so much for doing this. So yeah, we'll skip our introductions, but yeah, we can actually do the introductions as well because some of you might be new. So my name is Sayam Pathak, and I'm the founder of Keep Simplify and also Build Safe for supply chain security. And currently I'm working as a principal developer advocate at Loft Labs. And I'm the tag lead. This time I won't forget. I'm the tag lead for the CNCF tag sustainability. And we are doing a lot of initiatives over there where you can get involved. For that, you can watch the previous stream in order to know more about what the CNCF tag sustainability is all about. What are different working groups and how you can be part of that and get involved and contribute to these initiatives, because these are all community-led initiatives. Divya, over to you, and then we'll move to Kate.
So I'm going to keep it short as well. Hi, I'm Divya, and I currently work as a principal technology advocate at SUSE, over and above which I am a maintainer for documentation on the Kubernetes project, help build the community around the WebAssembly ecosystem, and I'm also the lead for Chaos Asia. I can't now take a jibe at Sayam because he forgot to introduce himself. He did introduce himself today. So over to you, Kate, with your introduction.
Well, first of all, it's great to be here. I always love spending time with you both, and all the times we get to connect, whether in person or online. I am Kate. I'm a senior software engineer at Fermion, and we're a startup that focuses on making it easier to build serverless applications that are backed by WebAssembly. And I'll talk a little bit about why that's exciting later. I came from a Kubernetes context, so I'm actually co-chair of the CNCF IoT Edge Working Group, which used to be the Kubernetes Edge Working Group. And currently with Divya, I do a lot of documentation with the WebAssembly organization, which is the Bytecode Alliance, and they focus on WebAssembly on the server initiatives. And I'm co-chair of the documentation SIG there. And so there's a book where you can learn all about WebAssembly, and Divya and I have both put a good bit of time in there. And then outside of work, I love to be outside, and I volunteer instructing mountaineering courses. So if you live in the PNW, I can always relate to great hiking pictures, even if you're not there. But those in particular make me enticed to want to go where you just went.
All right, I think we should get started, Sayam. Do you want to set the ball rolling with the first couple of questions for Kate that we have today?
Yeah. So first thing is for setting the context for the audience who is new. So Kate, you have an extensive background in WebAssembly. You have given various talks and spoken to a lot of people about WebAssembly. So if anyone, and I have a WebAssembly course on this channel, so probably people should be knowing about WebAssembly. But if anyone is joining in today and they do not know anything about WebAssembly, so what would be your very short introduction to WebAssembly for them?
Yeah, I think of WebAssembly as two things people should think of. One, it's a compilation target, so you can take any language of your choice and compile it down to this universal bytecode. This is that .wasm file that you can now run anywhere where there's a WebAssembly runtime. And that WebAssembly runtime can be a myriad of different runtimes, but it then takes that WebAssembly module or component and then executes it in an isolated sandbox very efficiently. So now you have this isolated, fast, polyglot, portable artifact. And so you can run it on cross operating systems and cross architectures, and you don't have to do any more cross builds, and you're set to go. And I would love for you both to also add anything that you would as well from the best ways you found to explain WebAssembly.
I think you explained it really well, because it is a kind of what Java wanted to become long time back, but only specific to a particular language. But here you can think of it as like you write code in the language of your choice, and you're still able to compile that into a universal kind of bytecode, which is a .wasm file, and that you can run on any system out there. So it gives you that power and flexibility. But not only that, it along with that, it comes with instantaneous startup times. Obviously, that is one of the core key topics that will drive the whole conversation today, and also a very secure sandboxing. So these three key main components make WebAssembly very good. Initially, it was created for the browser. It saw its success. You can search on Google, and you can see a lot of interesting talks as well, like how WebAssembly is being used at Google. There's a very good talk that they did at Wasm.io, and you'll be able to see, Google Earth and Google Sheets and everything, how they are kind of using WebAssembly. Then Adobe Photoshop, how they, they use WebAssembly to power the very heavy software. So these are some of the very success, like we call the success stories of a particular technology. So these are those. And then there is a group of people who have been started to think, how we can use the same thing, same principles, because the benefits are huge on the server side as well. And that's where they started to think, form a group, form some interesting initiatives, like Vazi. So Vazi was the first breakthrough that led to this whole idea of running WebAssembly on the server side, making it possible. Because when we talk about secure sandboxing and we talk about server side, then how do you access the server? How do you access the file system? What do you do with that? So that's where Vazi came in. And then you have the implementations as different runtimes like Wasm Time, Wasm Edge, and so on and so forth. We have different runtime implementations of that you have on your systems, and you are then able to run your WebAssembly workloads on server side. So yeah, that's my short introduction to WebAssembly.
And just to add to that, since we kind of dove in there, I think a couple things that we haven't mentioned yet, because we've mentioned so much about WebAssembly already, is this .wasm file is incredibly small to other code artifacts compared to other ones. So say you have an Express.js app that you compile to, that you build as a container, that can be 300 megabytes potentially. Ideally, you get it down from some container optimizations. But if you write that as a WebAssembly component, 3 megabytes. And when we talk about distributing these, you can distribute it as an OCI artifact. So if you're not familiar with the OCI spec, you can actually distribute artifacts other than containers with OCI. So you can distribute this .wasm file with the same tooling systems that you're used to, which is really exciting. And then to also touch on the security, we mentioned how it's sandboxed. But we also, one term that's helpful to think about when you think about WebAssembly is capability-based security. So a WebAssembly component cannot do anything it hasn't been explicitly granted access to do by the host. So if you think about Log4j, for example, a random call home to some outgoing host, you would never be able to do that in a WebAssembly component because WebAssembly components can't make outbound HTTP requests unless explicitly granted. And when we talk about Spin later, we can talk about how with Spin, which is the developer tool I work on, it gets even more granular than that. It makes it so it's easy to define what explicit hosts your component can speak to. So you have to be very definite about what you expect your function to be able to do. And in that way, it's great to know that it won't do anything more than it should.
And I just want to add one last piece that you all both have surprisingly missed, just to complete the whole jigsaw puzzle before we even start. When we're talking about sustainability, and I'm pretty sure we will be covering this in the session itself, a lot of things have to do with the amount of efforts expended and the number of CPU cycles that we consume and the number of resources that we use for testing and stuff like that across different languages for the same bit of code, right? And like you said, it's portable across languages, but with the introduction of the component model and the direction in which it is going right now, the concept of a plug and play architecture, so to say, when it comes to software development is also quickly becoming a reality, as opposed to it just being like a theoretical and fantasy related concept, right? Like, we all wanted to have those plug and play architectures that used to work across languages so that we didn't have to expend efforts across the software development lifecycle for the same bits of code. But with the ongoing development in WebAssembly, in the form of the component model and the WASI spec, I think that's another aspect that we probably will cover during this session. So yeah, I think we've set the context pretty well for what we're going to talk about in the next, I don't know, 20-25 minutes.
Yeah.
Yeah.
So yeah, let's move to the sustainability angle. So Kate, why why WebAssembly matters when we talk about sustainability? What are your thoughts on that?
Yeah, and when I talk about WebAssembly sustainability, I personally think it's helpful to think of it from a perspective of serverless. So I first want to talk about why serverless is helpful for sustainability when done right. So the idea of serverless is that you define a functional unit of your application that should be able to be executed instantly and torn all the way back down. So when you're doing work, you scale up, and when you're not doing work, you scale to zero. And in an ideal system, that's incredibly efficient. If I'm only doing work when I'm supposed to be doing work, and each one of those serverless units is isolated, I can create this multi-tenant environment where I can host thousands of apps, and each one of them is running when they run and tearing down when they're not. And I can use less hardware to do the same work. And if you're familiar with software carbon intensity, that a formula that will bring down your software carbon intensity. Whoa, my wing just shut my door for me. That will reduce your software carbon intensity, and in that way you're able to run your application feeling better about yourself in some way, and that also reduces your cost. Today our serverless solutions are not as efficient as we would like, and that's in part due to the underlying technologies they use. So you may be familiar with AWS Lambda, which is one of the most well-known serverless solutions. The underlying technology there is the micro VM, and micro VMs can take upwards of 500 milliseconds to warm up. So this is before we even started executing our application. We're using resources, and I actually have a slide that might bring a visual to this. We can look at that. Yeah, and what a serverless, we've covered that a little bit. So yeah, let's look at kind of what exists in serverless today. So one problem we have is we're spending more time waiting for our function than we are actually executing it. And so these are resources that are being used that we ultimately, as users of serverless platforms, have to pay for. But also that means that the hosts of the serverless platforms have to provision more infrastructure to be able to handle all of your requests. And because of this, what Lambda does is they pre-warm all your instances. So they're running even when you're not executing them, which means that they can achieve less density on their hardware. It does mean that your latency is brought down to like 125 milliseconds on average, which is still quite high for serverless or for a user in general, what we expect from latency. Containers have a similar issue. So Azure Functions is container-based, and 81% of those are invoked once per minute or less, which means that it's just enough that they have to keep the containers running, but not enough that it's that useful to do so. And so that means that it's becoming very high, very costly for Azure to host that service, because people are paying each time they use it, but they're actually having to provision a lot more infrastructure. And Kubernetes in general, because we're talking about cloud native stuff, has an issue with resource usage. So 80% of container spend is wasted on idle resources. And part of that's because of improper resource requests on containers. And then finally, 69% of CPU cores in Kubernetes were unused. So that is just not a great number when it comes to resource usage. And I just want to talk about why that is a problem. There's this concept of non-proportionality of energy consumption. So you may have thought, oh, if there's 69% of CPUs being unused, that means I'm only using 31% of my power. Unfortunately, that is not the case. If I'm just using 10% of power, it's 10% of the capacity of my machine. I actually am using a third or 2/3 of the power of my system. And so the idea is the more of your system you use, you're actually using just marginally more power. So we want to use our systems as densely as possible. So that brings into WebAssembly and some of the stuff that Siam and Divya pointed out. WebAssembly starts up in less than a millisecond. So that is without warming, cold start invocations less than a millisecond, which means we don't need to pre-warm anything. We can execute it on request. And so in that way, we can have highly dense platforms. So for me on the company I work on, we have a serverless platform for WebAssembly, and we're able to host thousands of applications on a single WebAssembly runtime on a single node. And that's because we only execute functions when requests are received, and we scale all the way back down to 0. So that was a long answer, but I wanted to provide context on why the serverless we have today is not achieving the goals of serverless, which is this dynamic scale up and scale back to 0.
So, Kate, can you delve into a little more about how WebAssembly actually does all of this? Like we spoke about the 10,000 feet view of how it does it. Like we all mentioned like snippets of, hey, you know what, WebAssembly does this and this. But can you just like give a more deep introspection of how that actually works when it comes to like maybe the lesser startup times that we spoke of, or even like how it's an effective virtualization layer, or how the plug and play architecture, like can we like dip into each of these points a little bit more in detail, so that our audience understands this better?
Sure, I can talk about the isolation mechanism and kind of enough to show how that is so much more efficient. So WebAssembly is isolated in linear memory. So essentially what the WebAssembly runtime does is it chooses a chunk of linear memory, and it will load your WebAssembly component into that chunk of linear memory and then execute it. So when we talk about how long does it take to start a WebAssembly component or a WebAssembly function, it's reserve linear memory, loaded in there. And there's one step before actually, when the WebAssembly runtime gets a WebAssembly component, it does need to then compile it to native code. So a lot of WebAssembly platforms like ours will pre-compile that to native, and then on each invocation that's already done. Same with SpinCube, which is an open source tool or an open source project for running WebAssembly on Kubernetes that also does pre-compilation on the first deploy, so that when you then need to execute it, it's quite fast. So you just basically take that natively compiled artifact, load it into that chunk of linear memory, and start. And so that is its isolation, is that it cannot leave that block.
Yeah, and I think you also mentioned that uh, like in the introductory section, that compared to containers, it's got a faster startup time, which is obvious because of its lower size. Are there any other touch points that you want to cover in terms of how in terms of sustainability, WebAssembly actually trumps or performs better in comparison to containers?
Sure. I think one that a lot of us open source developers or just GitHub developers can relate to, or actually not just GitHub, but a lot of us have to compile our code to then distribute. And if you think about the actions that you create to do that, so GitHub workflows, you're having matrices of cross compilations and distributing 4 versions of your artifact for different architectures. And with WebAssembly, you only have to run that workflow once for that one .wasm artifact, which also means the path to mitigation is more sustainable. So imagine that you have a application that's composed of 4 different WebAssembly components. And there is some vulnerability in one of those components. You can actually say it's an upstream component. You could just pull down the patch component and recompose the components. And this gets into a little bit of the power of the component model. But the 3 remaining components do not need to be rebuilt or anything. It's just that one remaining component. So build times and the amount of energy that goes into that is also reduced.
Right. And when talking about the performance context in general, like clearly it trumps the container side of things because of the things that you just mentioned. And it's also an effective virtualization and isolation layer. Um, what about from the performance standpoint? Like, how efficient is it in comparison to all the other existing? You know, levels of virtualization and levels of technology that we have currently?
Yeah, I think when people talk about execution time for WebAssembly, it depends on the language. I will start off by saying Rust is probably one of the best supported in the ecosystem, and Rust is near native speeds. So it's about 2.5 times slower than native execution time. And but that's with like getting all of the isolation you're getting. And so execution time for Rust WebAssembly functions is a negligible difference there. So when we're talking about a running instance that you're executing compared to a long-term running container, you may find that execution time may be a little slower for WebAssembly. But the difference here is that when you're not running the WebAssembly, it's torn down. So when you're running your container, it's still constantly running. So if you're willing to take a tiny, like most people would not consider that as a performance drop, WebAssembly, but also be able to do more with your hardware, pay less to provision less hardware, and so on, then WebAssembly is the solution. We actually, for Fermion, our website is run on our infrastructure, and we joked that our t-shirt bill was more expensive than our AWS bill which was actually the case at one point. We then bought a lot more I was going to say we bought more t-shirts, but we then did build out our AWS bill a little bit more there with Fermion Cloud. But at one point, we were actually not paying much at all to host our own infrastructure.
Amazing. So yeah, I think that's what every resource utilization that you can do, and you can use all the resources and not waste it, and you can use it intelligently, and especially with the WebAssembly powers, the size, speed, and all these, they all contribute to using less resources, using the resources efficiently, and also how WebAssembly can actually help with the serverless ecosystem that Kate just mentioned, and how that relates to the sustainability part of that. Switching gears to AI a bit, because AI is something which is obviously talk of the town now for a long time. I think it's just 2024 October. So we should also talk about AI, right? Without AI, nothing, no stream should happen without talking about AI. So when we talk about AI, specifically the inferencing part, how does WebAssembly plays a crucial part in the AI inferencing? Because I know Fermion has done a lot of a lot of groundwork in both in the WebAssembly and AI inferencing space, and you folks have been pioneering this. So what are your thoughts, and what do you have to say with the WebAssembly and the AI inferencing ecosystem?
Yeah, so to your point, Siam, when everyone was trying to find some way to bring AI into their product, we also had that crisis. So we're a serverless platform. So we were wondering, how can we provide inferencing from these serverless WebAssembly functions? And how can we do it in a way that's not too expensive to us as a platform, as a startup, and make it as efficient as possible? So we were kind of driven by that constraint. And what we did is we looked at the way people were doing inferencing today and how costly it was. And that's in part because you can only run so many inferencing requests at once in parallel using a GPU. And so we wanted to think about other ways you could share a GPU. And we thought about time slicing it instead of physically slicing it. And so what we did is we created a service that essentially creates a queue of incoming inferencing requests, and those queued requests are offloaded one by one and executed and returned. And the amount of time to do that actually was negligible, to queue people up in their inferencing requests and return them, because all of our models were loaded in memory and ready to go. So we didn't have to handle switching between models as well. All of this is to say, we provide serverless carbon neutral AI inferencing on Fermyon Cloud. And I actually have a slide to kind of show how we're doing this as well. Let's see, we're gonna have to jump a little ahead. Okay. And once again, this multi-tenancy word is a key word here. I'm a little passionate about that word, but if you can increase multi-tenancy, you can improve software sustainability in general. And I'm happy to talk a little bit more about that as well. But the way we do carbon neutral AI inferencing is we're actually using, one part is that efficient scheduling and executing of inferencing requests. And the other part is we use Deep Green. Deep Green, what it does is it's a company that takes your servers and takes the externality of the heat generated from them and puts it to use. So in our case, our servers are, the heat generated from those servers are heating a swimming pool in London. So with KubeCon, EU being in London next year, I want to find this pool and I want to swim in this pool. But yes, so that is whenever you use serverless AI with Fermyon Cloud, that is what you're doing. You're heating a swimming pool in London, which is quite exciting. And you can actually use other common practices with inferencing, such as caching results to make sure you don't forward inferencing requests multiple times, because Fermyon Cloud also has data storage. So you can use key value stores or SQL databases from Fermyon Cloud. And you can also do custom embeddings and semantic searching for inside of Fermyon Cloud's databases as well. We're backed by Terso, which has great support for all of those. So yeah, that's kind of the large span of it. And actually with Spin, our local developer tool for it, if you don't want to use your CPU to run inferencing requests, because you surely do not, that will take a long time, at least like 20 plus seconds, you can actually offload those requests to Fermyon Cloud with a plugin as well, and run it on that intensive compute.
Awesome. Yeah, I think AI influencing using WebAssembly is really a very interesting topic. I have given a couple of talks in the past, and I've also given a talk at past KubeCon with Mark from Deep Green on Deep Green, like how it works. It's pretty interesting and cool system that they have built, feeding up the swimming pools. Awesome. So Kate, you also touched on the little bit. Let's dive a bit more into the WebAssembly versus traditional containers. So we had this Linux servers. We saw a shift towards running it as containers. So with the view of sustainability, how would you compare WebAssembly with traditional containers? I mean, I'm calling it traditional containers, but it's not old. Containers are still used. So just for the comparison, I'm saying like WebAssembly versus containers.
Yeah, and I think when you're talking about old versus new, one thing that Matt Butcher, the CEO of my company, has described to people are the waves of cloud computing, and the idea with that with each new wave of a new way of going about designing our applications with new technology, we still use the old wave. And so we can think of the first wave of the cloud was virtual machines, where we can virtualize hardware and run applications next to each other. The next wave is containers, where now we're virtualizing services from each other, and we can scale up one and scale up the other, and so on, and we're virtualizing the operating system. And then micro VMs, such as what AWS Lambda came in, and we have now serverless. And so you can see how with each of these waves, we're increasing multi-tenancy. And that's that word, once again, where I get excited about. And so in my opinion, the more multi-tenant a platform you can get from that underlying unit, the more sustainable it is. So when you're asking containers versus WebAssembly, I would say WebAssembly has more sustainability in part because it leads to a system where you can increase multi-tenancy. And so after micro VMs, starting this concept of serverless and making it realized in platforms and fast platforms, now WebAssembly, we can achieve even higher levels of multi-tenancy and be just as isolated. And so even WebAssembly compared to micro VMs is a more sustainable choice there. But there are limitations to what you can do with each of these waves as well. So that's also important to keep in mind, is we're creating new developer experiences with each wave. Containerization required a new toolkit for people and them to build their applications in a no longer monolithic way. And same with serverless. It requires you to think about how your application is designed in a little bit different of a way.
Awesome. So yeah, we have seen and talked about a lot of benefits of WebAssembly, but what are some of the challenges that you think, some of the challenges, and also how these challenges are creating new opportunities and leading the path to new innovation in the space?
Yeah. There are certainly limitations with WebAssembly. And I would say the original challenge to WebAssembly was people were there was lacking maturity, and that was, I would say, a few years ago. And now there's multiple platforms, runtimes, toolkits to make it so that's less of an impediment. But there are still limitations to what you can do with WebAssembly. And those limitations are oftentimes what interfaces, what WASI interfaces are available for me to do host level things. So you mentioned WASI earlier, Siam. To give an example of a WASI interface, one of them is WASI HTTP. So that defines how you can do HTTP requests from WebAssembly component. Another one is WASI IO, which defines how you can do IO from a WebAssembly component. Ones that are being developed now that are not yet there is WASI Web GPU. So right now, people want to be able to do more direct interactions with GPUs from their WebAssembly components, right? You can't do that right now. So what we do with our AI inferencing is we're actually sending out an HTTP request to do that inferencing to our inferencing service. Other examples are WASI key value. So Spin, we've defined our own key value interface, but there's actually work within the Bytecode Alliance to define a key value interface that everyone can use, so that you can take your WebAssembly component and run it on Fermion Cloud, and then you can also run it on a different provider. The cool part about this is there's no vendor lock-in if people use WASI and all of its interfaces. So while with AWS Lambda, you were locked into using that Lambda only there, you can actually create a serverless function based in WebAssembly and then decide, I don't like how that platform's providing me services, or I don't think they're as sustainable and using green enough energy, so I'm going to switch. And you don't have to rebuild your application as long as that platform is providing you a WASI-based host, which is really exciting. And that's why a lot of companies are coming together to create this universal way of running WebAssembly and these universal interfaces. Other limitations would be, like I mentioned earlier, certain languages are faster than other languages. JavaScript has room to grow for sure on its execution time in WebAssembly. And part of that is that we are compiling the interpreter as well to WebAssembly. And also a lot of that is stuff that I don't fully understand, but that a lot of great minds are putting to on how to optimize it. But right now it is not as efficient as we would like for executing it. The other thing would be just packages that are available to use. So say your ecosystem is Python. Now you can use pandas libraries in WebAssembly components, but you couldn't a year ago. So that's an example of how the ecosystem is evolving and what is available now may not have been available a year ago, and also further that way in a different direction.
All right. And I think we touched upon a lot of the sustainability side of things, but I'm very curious, Kate, to see and understand how it is being used currently, right? Like WebAssembly's use cases currently, how would you term it in like the overall technology landscape? And where do you see it growing from here onwards?
Yeah, so I think there's categories of where WebAssembly is being used. So I think you mentioned, Divya, like the plugin model is one of them. So I want Shopify uses WebAssembly plugins so that you, as a Shopify store owner, can plug in more functionality to your store. There's also processing, so basically pipeline ways to improve that with WebAssembly. So Amazon Prime Video uses WebAssembly. I think they're one of the biggest consumers. Adobe Online uses WebAssembly. And so you have kind of that middleware as WebAssembly solution as well. And then you also have the IoT world that is looking at WebAssembly a lot because it's fast, portable, small, all these things that you want to use on small constrained devices. So there's Whammer, the WebAssembly micro runtime that people are using in a lot of embedded scenarios right now. And then there's cloud, using WebAssembly to run your cloud services. And that's the area that we think about with Fermion, and that I'm the most familiar with customers around. But one example of a company that has been looking at switching to WebAssembly is the Zeiss Group. And so they were using a containerized based serverless solution, and they did a POC essentially of switching to SpinCube, which is running WebAssembly on Kubernetes, and found that in doing so, they were able to reduce the cost of their system by 60%, which was quite impressive. And part of that was because once they switched to WebAssembly, then they could also change the infrastructure of their VMs. So they were able to add more ARM nodes into their VMs, which were less expensive. So you have that compounding factor of once you switch to WebAssembly, you can also make better architecture choices, such as like region shifting for sustainability purposes. I would love to hear if y'all are familiar with other production use cases that you've come across as well.
I think you covered pretty much all the cases that I knew of. Sayam, I don't know if you're aware of any of other use cases, because these are the most popular ones that I have also heard of, to be really honest with you.
Yep, agree
All
on
right.
that.
And I think with that, the next thing that we probably want to understand is this is from an industry perspective, but what about the future of WebAssembly and green computing? What about that intersection? Given that this is the Cloud Native Sustainability Week, what about the intersection, and what about the future of that intersection? How do you see that moving forward?
I think WebAssembly is gaining a lot bigger adoption. A lot of big companies are using it. Microsoft has been really developing a lot of WebAssembly. And I think that is important because WebAssembly was a newer technology when it comes to using on the server and was spending time establishing legitimacy. And I think it's established it at this point. And so I think a next step would be for companies who have green initiatives to start requiring more use of it, in the way of being able to improve legacy code with plugins so that they don't have to spend engineering hours rebuilding it, and the ability to maybe add some functions to their services with just adding WebAssembly. And the reason why I think kind of putting the icing on top with WebAssembly is helpful is that you don't need to rebuild whole systems, spend engineering hours, and also spending compute hours reprovisioning everything if you can just find an easier way to make additive systems. The other thing I want to mention that we haven't mentioned before, and this doesn't directly relate to your question, but I just thought of it, was that with the component model, I can take a Python component and compose it with a Rust component. And why this is exciting is that, say we all think that Python has the best universal URL library. We can all use the Python provided library from every language. So I no longer have to create a new library in Rust or in Go or in TypeScript. I can just use the Python one and bring that into my application. And that's quite exciting when we talk about removing redundancy from computing ecosystems.
And I think one of the things that you briefly touched upon in terms of like reusability of components and not just components but other stuff as well in the WASM ecosystem, that leads us to the next question. It provides a natural segue, I guess, to the future of the tooling and the WASM ecosystem in general, right? Like we talked about it from a green computing perspective. Um, what are some of the current tools that you think are interesting from a sustainability point of view, and are there any things that you're aware of that are being developed in the ecosystem towards this goal, or is this something that's like just a very natural way that wasn't takes because of its inherent portability and security and isolation features that it offers?
Yeah, so I'll start with the second part of your question and then aim to move back to the tooling. But I personally think it's inherent. That's why I moved to the WebAssembly space and was so excited about it when I first learned about it. Is I think in my opinion, some of the best environmental solutions are ones that people aren't aware they're using. It's less overt, and so I think by using it as an underlying technology, you improve the green posture of your technology. Um, I'm not aware of any projects that are built off WebAssembly that are focused on improving sustainability, but I'm sure there will be some and probably are some, just as in people are constantly developing great tools and projects that help with specific sustainability concerns. Um, on the point of tooling, we mentioned the Bytecode Alliance that Divya and I are both involved in quite closely. They build a lot of the tooling needed to build WebAssembly components and do lower level tooling. Most of the platforms and CLIs that are out there are built on top of those. So they're aiming to abstract away the details of those. But I will say, if you're interested in kind of getting involved in building out that tooling, I would look at the Bytecode Alliance's GitHub organization. Some of the big tooling that people use is WASM tools and WAC and Whackage. The names are all W's, so if you remember that, congratulations. But the big one to take note of is the fact that the whole ecosystem is moving to being more registries based, and that is coming to fruition very soon. And the way that you can pull a universal component down from a registry, push up a interface for other people to use, and all of that tooling is kind of being finalized. WAC stands for WebAssembly Composition, and it makes it so that you can use a language to describe all these nuanced ways you're composing your WebAssembly components. And then Whackage makes it easy to pull in those different components and interfaces from registries. So that's all a teaser. If either of those toolings seem interesting to be directly involved in the Bytecode Alliance GitHub repo, and there's also a Zulip where people are chatting and developing WebAssembly, would be a great place for that. And if you have a use case that you're interested in seeing if WebAssembly has a good sustainability angle for, Zulip's also a great place to ask the maintainers of WebAssembly those questions or get their advice, because people are always very active there.
Awesome. So I think, yeah, we have covered pretty much all that we have on the agenda. So basically, I hope everyone watching now or who will be watching later, you get a gist of obviously what WebAssembly is, how it fits with serverless, and how serverless fits with the sustainability ecosystem, how it fits with containers, and how they both compare to the sustainability ecosystem, how it fits and sits in the AI inferencing space, and then how it again helps with sustainability. You have seen that deep green diagram and how efficiently it is using GPUs, also the green GPUs. So touching all stacks. So touching the hardware level, touching the technology level, which is WebAssembly, and then putting AI inferencing on top of that. So kind of giving a very neat combination of doing it in a very, very sustainable way and a green way. And also some of the cool new things that the community and the whole ecosystem is evolving to. There is a conference called Wasm.io, which I really like. It like the first one I think for WebAssembly was Wasm.io 2 years back, and they did a second edition this year, and next edition will again be next year. Obviously, the CFPs are open, so if you're interested, that's a very good conference that happens in Barcelona. I and Kate have spoken there together as well. So it's really good conference, and Divya, you have missed it twice, so you should not miss it the third time. You should try and make it to the conference this time. Yeah, if anyone has any questions, or Kate or Divya, you have last minute thoughts, please feel free to speak up.
I'll also add that WasmCon is coming up, and it used to be a standalone conference, but now it's attached to KubeCon. So if you want to go to KubeCon North America, if you want to go to Salt Lake City a little earlier, get in on Monday, you can start participating in WasmCon. And there's actually a lot of that agenda is use cases of companies like Amex who are using WebAssembly in production. So if you're curious about learning about the low-level parts of WebAssembly while also learning about how it's used today, that's a great place to do that. And I agree, Wasm.io is a great event. So I hope I'll be able to make it this year.
Awesome. So I think, yeah, we don't have any questions for now, but if you have any questions, drop them in the comment section once the video gets uploaded. And also, you can also reach out in the CNCF Slack. There's a WASM working group that you can get involved with. There are calls that happens, very interesting stuff that is happening. Also, there is this Run WASI project, which is very good. There is Spin Cube project, which is very good and very interesting for running your WebAssembly applications onto Kubernetes cluster in a very, very simple way. And obviously there is Spin, which is open source as well for making it easier to run WebAssembly, easier to create the WebAssembly applications from scratch. So I think you should definitely check those out. I'll put the links in the description. And if you have any questions, feel free to check them out. I have a course on WebAssembly that I and Rishit have created, so check that out as well. And yeah, if you are at WasmCon or Salt Lake City, we'll be there. So feel free to reach us out in person too. Well, that's pretty much it. Divya, any closing thoughts? All right. Tomorrow we have another stream with Lucas, who will be telling about where we'll be discussing about the Kubernetes resources optimizations using different techniques. So make sure to attend that as well, same time again, so that it, we always try to keep the same time and the day, so that it keeps fitting that every day there is something new and interesting to learn. And the theme is sustainability, and we try to cover different spectrum. So I hope you enjoyed the stream, you liked WebAssembly and sustainability, and if you want to try out, please feel free to try out all the resources. Thank you so much for watching, and thank you, Kate, for doing this, and thank you, Divya, for being my co-host for today.
Thank you for having me. And one last thing before we go, I realized this just right now that we have actually done a stream with the Deep Green CEO last time around. So we've been referencing that throughout this session, and Kate's put up a slide. Sayam talked about it, but it just struck me that we've done a whole session with the Deep Green CEO last time around.
Last time, yep.
Very same week. So if you have questions around that, please refer to that video, because that was a very, very in-depth discussion that we had with him. And of course, if you have questions, please do leave them in the comments. We'd be happy to get to them as and when we can. But yeah, I just felt like that needed to be said, because we did do that last year.
Yes, exactly. So we did a stream with Mark from Deep Green last year, and how the infra level and data centers are working towards the sustainability, and they are doing really, really well. And there are a couple of others as well who are in the same space doing different household heating stuff, which is really very interesting. And for GPUs, because everybody's going towards AI, everybody needs more GPUs, which will need more electricity, more power. These initiatives are very important. All right. Thank you all, and see you tomorrow. Bye.
Bye, everyone.